Okay. Hey, yeah, this is Coffee Compiler Club. Anything to do with compilers and language runtime. I think everyone here has heard this spiel before, so I'll just cut it short and say you're being recorded, and let's get going. So besides defeating or being defeated by whatever, stalling out with Poison Oak, and spending a day on loan shuffling things, a full day, it was, mess. I spent the rest of the week on AA hacking and making good progress now. Now my theory feels, once more, my theory feels correct. Charging ahead, putting it back into the mainstream set of things. I'll leave it at that unless people want somebody last week wanted to do stuff there.
It was me, but I asked a few questions about the type resolution and the monotonicity thing, and we reached some kind of conclusion, but we can go there if people want.
Yeah, whatever people want on this side. I think I got my types sorted out now. I thought that before. I got a lot more testing behind this one, so I'm more confident than ever.
Oh, cool.
Cameron, you were asking me a type question as well.
Indeed.
Did you want to go on that one instead, or do you care?
I'm eating right now, so.
All right. Well, I can go first, but I don't have anything official. I don't have any pretty documentation.
That's why my video's off, by the way, so you don't have to watch me chew.
Oh, I see. Yeah. Okay. Well, I'm not showing my legs off either, so it's all fair game.
I was going to say also because I don't have pants on.
You didn't need to say that, so it's all good. Yeah. So the theory is that I've got a Hindley milner combined with a classic C Java style typing that gets the best of both worlds. I need to figure out a good way to present examples. Let's see here if I can do this way. I'm going to bring up Emacs here, and I'll have to do the font shrink thing. And no, not this one. I want this guy. Yeah, okay, here we go. I don't know if this is like super exciting or not. Let me bring up screen share. Yes, no, this. Find Emacs. Okay, font's probably too small, right? People see that?
Slightly.
The font.
We can increase it a little.
Yeah. Okay.
That's fine.
Yeah. Okay. Fine. So this is a series of 70 or 80 tests.
Mm-hmm.
The test is the first line. The second line is the result I get out of a Hindley milner analysis. The third line is the result I get out of a flow analysis. And then more complicated tests have doubles of the same things, showing what happens when you get the combination of them both. So the programming text here is a classic lambda calculus syntax. Curly braces start a function. X is the argument. Parens to application. So this is a super simplified lambda calculus style syntax. So I'll show some more.
Mm-hmm.
And this just is X is a function that takes an X and returns a pair of 3 and X. And if I look at the Hindley milner result, A is a generic unspecified type variable. Let me actually shrink my Emacs window, which grew with the font, and suddenly it's off to the right and I can't do things. And it's too tall, and now it's too short. Now something else went to the front. Stop that. We can't grab it now because it's, there we go. Better. Okay. Yeah, fine. So the test 02 here is the start of very simple things. It does an obvious thing. So this is the Hindley milner result. It's pretty straightforward. The syntax on the flow result has more data and is more complicated. So let me step through what it's showing, because a lot of it's meaningless or not meaningless or something. So the bracket 8 bracket in front of the curly brace says which specific function. There are some 15 or 16 primitives which get the first 15 or 16 function numbers. but 18 is then one-to-one mapped to the function in the program text here, this function. So Hindley Milner gives me a type for the shape of things. The flow gives me, in addition to a shape, it gives me specifically, here we go, gives me specifically what it is that, which function is involved in many cases. Same for which alias involved for allocation sites. So I get much more precise information. Then I have a curly brace. There's some anything which will be a display variable, which which has no meaning in this version of things and has a lot of meaning in AA. Because in AA, I'm using fat function pointers, and this is the type of the fat function pointer. So no exciting type theoretical difference on fat function pointers versus not. It's just you're carrying an extra argument around on the function pointer instead of on the arguments. So when the function pointer is added to an application site, you come with an argument already. This is the type of that argument from the flow side. I'm using some shared infrastructure, so the flow types always know there's a display involved, and they pretty print one and they parse one. So I just included it, but it's always any, not used, top, ignored in this set of tests and this sort of pure lambda calculus syntax. 3 is the count of arguments, of which the first 2 don't count. So there's one argument. First 2 arguments are control and state of memory, which don't count in the lambda calculus. So just subtract 2. You get one argument function. The function, there's the arrow. And you notice there's no type on the arguments. So I'm giving you return types, but no argument types on the flow side, because they come from how the arguments come in instead. 7 says I'm at the 7th alias for a memory alias. So here is an open round brace. That's a tuple. I'm generating a tuple. It's from allocation site number 7. So I'm generating a pointer to a tuple, allocation site number 7. He's got a display, which is always ignored for tuples. It matters only in AA. So again, it's another ignored field. A 3 and a generic scalar. I don't know what the hell the type of X got passed in. So I'm going to declare it a scalar, which is any finitely sized type that I can fit in some set of registers. And then, close the tuple, close the curly. So a little bit more stuff in the flow side, makes it a little harder to read, but if you skip the ignorables, if I went through and said, hey, you don't care about this, this says there are 3, hang on. There are 3 arguments, of which the first 2 don't count. So there's 1 argument. So that's the count of arguments. And I'm returning you this. And then of course, 18 is which function, of which there's only 1. That's very boring. Which allocation site, there's only 1. So this is the flow side return. And you'll see it's extremely similar to the Hindley Milner return, right? A little bit pretty printing differences. So that's how to read those. More effort spent on discussing how to read them than to actual think about them. So let's look at a step down the line here, because the first several guys get into what goes on with Hindley Milner in general, and then 5 and 6 highlight what Hindley Milner does that you can't get out of flow typing. So here's a function which takes an argument z and produces a pair which has z followed by a nil or z followed by a string. So z is a function which takes a nil or a string and returns a result. So Hindley Milner types this as your first argument is here. It's a function which takes a nillable string and returns me an a, and then returns me a pair of a and a. So this is just the type analysis for this program here.
So just to clarify, that 0 is just nil. It's not going to be any arbitrary integer or something like that.
Yes, and here in my world, nil is special because nil is an integer 0, and it's the nil pointer, and it's the 0 float, and it's the 0 function pointer to go along with the 0 alias pointer.
Tony Hoy would be proud.
Yeah. Where'd Aaron go? He's under Goldman. So nil is many things. I'm working with a lattice instead of a tree for subtyping, so it's not really a subtype per se. It's a member of the lattice that intersects with everybody. So again, here's the Hindley Milner
So-
result, which is, I just talked about it, string. Okay, here's the flow result. So the flow result has some function overall. That's 18 is the type given to the outer function here. And it takes some arguments, which are not mentioned, exactly one argument, and it's not mentioned what type it is, and returns me a pair of scalar. And in particular, I've lost the notion of what that A and A are the same type. All I know is they're two unrelated scalars. From the flow typing sense, that result could be 7 and the string cliff. They're not required to be the same type in any way.
This
So Hindley Milner
corresponds
knows something
to
here that flow typing doesn't.
the scalar, as you said, corresponds to an any or an object in Java.
Anything that's finitely sized. Yeah, so in my grand old lattice, control and the state of memory also exist, but they're not scalars.
Hmm.
So scalars will be 5 and pi and a pointer to a string cliff.
So as it is, how if you has to materialize the function at runtime, what would be its type? Object,
It
or
would be a something I can put in a register, but I'm not going to tell you what type it is, or even if it needs to be garbage collected or not. It's something that fits in a register. Finite
But
count.
if I have a 32-byte mutable array, that's not a scalar.
A pointer to it is exactly 32 bytes that is known at typing time to be 32 bytes is a scalar. Any finitely known sized thing. I can fit that in a bunch of registers, so then I'll declare it a scalar. Now, having said that, I'm not currently implementing it that way. I'll just give you the pointer to it. The pointer is the scalar. The pointed at thing's a memory chunk. I do have the ability to represent those in the typing system now, but I'm not doing so. Like the typing system can carry through any collection. A struct is just a collection of scalars. And if all of them, and the struct itself is essentially a scalar, and you probably want to put it in memory and take a pointer to it. But if you did a value struct, like Swift has value structs, it's just another scalar. Just takes more than one register to hold it.
So an array of scalars is a scalar, a struct of scalars is a scalar.
An array of unknown size is not a scalar.
So the scalar is an any with a known size.
Yeah, I would say it's an all with a known size.
Okay, that's fine.
Yeah, it's all of ints and
Oh,
floats and
but you
pointers to
know-
things,
but
and I
you
don't know which
know-
one you got.
How much space it needs.
Yeah, so you're asking a different question now. When it comes time to implement this thing, the current selection of scalars I have all fit in 4 bytes or 8 bytes according to the size of your programming model.
Okay, that's separate. Okay.
In the current AA that I'm porting the type theory over to, I'm allowing scalars to include structs which have multiple fields. They'll be the sum of their individual fields, and that will be the size they take. They'll take more than one register then. But the key difference is that a scalar has no memory location associated with it, and it's all identity is all done with bit by bit. They're bitwise. 2 scalars are bitwise. It's always passed by value. There's no pass by reference. As soon as you hit memory, you have an identity represented by the memory location you're at. And 2 different pointers to cliffs can be 2 different pointers because they point to 2 different chunks of memory that both say cliff, but they're 2 different pointers.
So if I have a pointer to an int64,
Yeah.
despite the fact that these things are all 8 bytes long,
As soon as you went to
the
memory,
top pointer is a scalar, but the pointer that's being pointed to and the int that's being pointed to are memories.
they're in memory, so they're a reference object. And I can pull them up. Any load will get at them and load them, but then you loaded the contents, and that got you the scalar. But what you pointed at, that's a reference.
Makes sense.
Okay. Sorry, go ahead.
I said that makes sense.
Okay, yeah, I wasn't sure if someone else was asking. So the last set of things here on the test is the set of aliases that I expect to see out of this. I got 1 allocation for the pair, so there's 1 alias, 7 for that allocation, so I had 7. I have a function number 18, which I mentioned is the overall function. There's a function number 19, which is not mentioned in the typing anywhere. That's because that's Z. which is a function that comes from the outside world. So I give it a unique function number. And like I said, I have, so the later writing people, I have 16 or 17 primitives in the pure lambda calculus version. So the function number started at 18. Okay, let's go to the next guy, and then 5 and 6 get more exciting. So here's fact is equal to a function which takes an in, which I then have an application of an if, which tests for equal to 0 and returns a 1. Otherwise, it's a multiply of n times fact of decrement of n and return fact, factorial. And Hindley Milner types it as n64 to n64. And flow typing, in fact, gives me a 1 arg function that returns an n64, and function ID is number 22. There are no aliases and only a function 22. So is that pretty straightforwardly here? I can do another thing here that makes this a little easier. Oops, this. So if I start doing this kind of stuff, and do some indentation, maybe like this a little easier to read. So this is factorial as a function which takes an in and then has an if, which if you're equal to 0, I return a 1. Otherwise, I multiply in times fact times decrement of n.
Doesn't we have to have else, or if statement is?
Well, this is the if else. So this is the predicate.
How do we recognize the else?
This is standard lambda calculus, which is treats if like it's a function.
Okay. Yeah, but yeah. Okay, that's fine.
And this gives you the type I64 to I64 because it wraps, so it doesn't go to like I64 or overflow.
Yeah, I'm not tracking, I'm doing overflow integer math only. So decrement of n here takes an n, it types it as an n64, returns me an n64, despite the fact that if you pass in min int and you subtract 1, you get max int. So it's a closed system for the n64s. Give an n64, you get an n64 out, and therefore it has to wrap. And that's the standard typing.
Which is fun. You've now defined factorial for negative numbers. It just goes all the way down and then loops all the way around and eventually makes it to 0.
Totally.
Take a while to run.
Well, depends on how big a number you put in. Yeah. Okay. So everyone get fact. It's pretty easy. So here becomes the first sort of excitement between 5 and 6. So 5 is an application. That's the outer parens of a function defined here with a second function, which is the identity function. It's all very boring. Make a pair where I apply the identity to 3 and the identity to 5. And Hindley Milner doesn't count 3s and 5s very precisely, so he rapidly becomes not 0, 8-byte integer. So nint 8. And his numbers are the same with and without combining with flow, because Hindley Milner doesn't track precision there. Whereas the flow guy can say, I can track the 3 and 5 through if I have Hindley Milner. So this is global constant propagation plus Hindley Milner. And this is the flow result. This is the GCP result type. And here. So if global constant propagation flow types, if flow types do not get Hindley Milner help, what happens is id takes in, they type this, GCP has to type this function. It takes a 3 in and it takes a 5 in both. So it unifies 3 and 5. Well, it meets them in the lattice, getting nint 8. This is a function which from the flow side point of view returns me a nint 8. So I get a pair of nint 8s out. Whereas let's look at 6 here, which is a little bit different, and the difference is all the difference. Id is declared to be a function of x to x, identity function. Make a pair with id3 and id string. And the difference here is that from Hindley Milner's point of view, id is applied twice. This version of and id is a function from A to A, from type to type. So this is a function which takes a 3 and returns a 3. This is a function which takes a string and returns a string. And Hindley Milner knows this. From Flo's point of view, this is a function. It takes a 3 and a string, has to meet them together, and decides it's a scalar. I don't know. It's 3s and strings. Yeah, what the hell do I do with that, right? So it's a non-zero scalar. So again, the result I get for Hindley Milner here is you get a pair of 3 and a string. Okay, the 97 is weird. That's because I don't have strings properly done. Right now, my strings are an array of characters of exactly one character, the first character of the string. So it's a cheat on the string. So the 97 is simply the ASCII value for the character A as the first character of the string. So ignoring that, I can tell strings that I don't know anything about them from constant strings by the fact that 97 exists or doesn't. All right. GCP without Hindley Milner merges the 3 and the string and blows out. Whereas, and with it, of course, he gets the full type. And up here, he at least gets something more precise. I'm sorry, it's the other way around. Hindley Milner loses his brains here. So I should probably rewrite the test to include strings on both sides. But the one thing going on here is id, from Hindley Milner's point of view, id is an argument that's passed in. It has to be the same function for both id3 and id5. Like I replace 5 here with a string, except I have to. Fine. It's a function which takes both a 3 and a string, which Hindley Milner, in a classic sort of ML, OCaml style world, Haskell style world, you just say type error and be done. You have a function whose first argument is both 3 and string. That's not allowed. In my world, that is allowed, but you fall to in scalar, and then like I don't know shit about you except I can pass you through. So all you're allowed to do with a mix of bad things is to copy them along. But that totally works, both from a type theoretical point of view and then the implementation in this particular world. And then this result would be changed, and my int 8 would be in scalars. Here, Hindley Milner gets sharper because it is generalized per use site. And that's the difference from Hindley Milner's point of view. So that's a classic thing you get out of Hindley Milner. This test isn't showing what I can get out of a combination of GCP and Hindley Milner in a strong way. It's simply showing Hindley Milner gains or loses something. Now, my version of Hindley Milner has a bunch of improvements to the standard algorithm. In particular, I'll pass constant values through that are not merged with anyone else and remain a constant, and I will type them in Hindley Milner as a constant. So classically, Hindley Milner would call this 3 here an int, and he would type the result here as a pair of int and string. And here I know my version is sharper because I carry the constant values through as part of the typing system.
So you said it's specialized per call site. So what's going to happen if there's 2 different paths to the same call site that leave you with different types?
Well, so here is exactly this. This is a function. Here are 2 call sites that have the same function. Are you asking a different question?
Yeah, if further up you have something that, if your function takes in a thing that may be a string and may be an int.
Yeah.
And then you have a call site in there.
Well, right here I have a function which may take in
I guess you would have gotten split already higher up if you had done that.
We should get a concrete example. Like the syntax is classic lambda calculus syntax here. We can just write something in chat or in Google Docs. Actually, Google Docs. You want to do that?
If I think,
I already wrote an example.
Okay, let me switch to sharing.
So it's in the Google Docs. So I tried to get the code block syntax right to look like AA, but I'm not sure I got the lambdas right.
I got fine. Okay, wrong thing. Yeah.
So this is the yeah. So
Yeah.
so it's okay.
Yeah.
I mean, I think I don't know. I don't know where the parentheses go. I couldn't figure it out.
Parentheses are only for application. This is a classic lambda calculus. There's no parentheses for grouping, no parentheses for order evaluation, strictly for application.
Okay.
So it's ugly if you have long nested expressions. It is.
Yeah. So like the one that's called term, I think that's the one that would be wrong because it has lots of nested applications because it's a lambda term.
Yeah, you have to get the order of evaluation of the applications correct in this syntax. You'd rather have parens for grouping, which I'm not doing because I'm doing classic lambda calculus, because I can make proofs and copy other people's code for classic lambda calculus.
All right, but anyways, but the basic idea is that the term omega, which is I think you had that in there. You had that in your document as a test. So like I'm pretty.
I
So
can put it in there. That's easy.
Yeah, so that one types. So the idea is that you take omega and you apply omega to both I and k, the identity function and the constant function.
Yeah.
And because
do people know why k is the constant function? So k is a function which takes an x and returns you a function which is the constant. It takes a y, ignores the y, and always returns the x, the constant x. So k produces a constant function. Sorry, go ahead.
Yeah, so so this is an example. I found it on the intersection types Wikipedia page, which is so intersection types are like my favorite thing now because intersection types can type all strongly normalizable lambda terms. So like they're universal in that sense.
Okay.
We may be talking about them next.
But so this
Okay.
example can be typed with intersection types. And it's
okay. So which example here? I claim I'll type all of these terms.
Right. And so
I don't know if I have intersection types or not, but I'll type them all.
So the question is whether you can apply omega at two different types without the type system barfing.
Okay,
and saying,
so if I look at your terms here, are they all well formed? Let's just go do this schmick here and see what happens, right? Other than I can't do omega in my Emacs. So let me come up here. Actually, let me hack Emacs for a second to get a test that's got this stuff in it.
I'll put the link in. Oh wait. Oh,
I'm
actually,
make a test case.
It wasn't Wikipedia. It was Stack Overflow. I'll paste the link. Oh, did my okay. Huh. I think your screen froze.
I haven't stopped the share on the Google Docs.
Okay. Yeah, no, it just took a long time for my link to show up. So, all right.
Of course, now I have to run this on IntelliJ. Let me go see what happens here. I didn't get any evil syntax errors. Cool.
Huh.
Okay. And Yeah, I'm blowing on a cert. So, you know, there you go.
Yeah, woo, I found a bug.
There you go. So let me, I didn't get far enough to test the exciting part. So let me force the test a little bit differently here. Let's see what we get. If I do Hindley Milner alone. Okay, so I can type this with Hindley Milner alone. My GCP is throwing an assert that I'll have to go track down, which I suspect is nothing to do with nothing. Let me go back to the Google Docs and throw you what I got for result, and we can tear it apart.
Okay, yeah, I guess if you just have recursive infinite, if you have infinite types, it might be.
Yeah, I have. Yes, I have the infinite types. So I other than the black on white. Okay, it's weird. So I hate the font coloring choices here. What the hell? How do you format text? No. Wow.
Yeah, someone made the code blocks black, which is not what we want.
I don't like that. I don't even know how to undo it.
I think it
now.
picked up your formatting from wherever you copied it from. There should be a way to paste it without formatting. I thought I saw that somewhere.
Hmm.
All right. Yeah, I got black on black going around, people doing stuff here. A little drop arrow, which says a table or something. Ooh, that helped. Now the font's too small, make it bigger, but you know, whatever.
Okay.
And I have this. Okay, that's my HMT result. Oh, geez. Well, here you go. Now I undo. I hit enter and it put a table line in it, and I was trying to tab it over. So that's a really horrific looking type, but it's a colon is a specification for a self-recursive type, and you're about to see what that spec is. I'm doing a little spacing, make life easier. So A is a term from A to A. Basically, it's the term for W. And then that's an argument to a function, which is then giving me an A to a B, where B is totally unspecified. That's the whole argument to another function, which gives me a B back. And I don't know if that's the type you expect, but that's the type I got for test.
Well, I mean, if you can type it, then I guess it's probably right.
Well, that's exactly the issue with these kinds of really horrific things that I have issues with. Like, okay, but what's it supposed to be? No one knows. Scribble a bunch of terms together and hit the type me button. You get an answer back. Is it the right answer? Is it the wrong answer? I don't know. Fine. But this one types, and you can see the A colon here is telling you that you have a self-recursive type. Let me show you the equivalent self-recursive type. Yeah, this is test number 7 from Emacs. I'm going to leave the things up in Google Docs. Here is test 07 from Emacs, and you can see it's just exactly your W term. And I type it and its friends, and GCP type it as well, straight up. So HMT type result, I get that for the type on it, which is F is a function which takes itself as its first argument, returns an F, and passes it to itself as a function, returns a B. Yeah, and B is unspecified anywhere. And it's because this function is only allowed to call itself recursively. Because it only calls itself recursively, it never returns. So B is never used. It is the return type of a function that never returns. So I have no trouble typing that kind of a thing. Like W is a little different because you're making the the two terms are forced to be the same, probably because how it's used inside the term area.
Okay.
And I have a GCP type for that number 07 as well, and it's very boring. It says, I'm a function, I take one argument and I return a scalar. So very, very boring function for GCP types for there.
All right.
So what I'd like to see now is what you're doing with what does intersection terms have to do with anything? This, in my opinion, has nothing to do with intersection terms, but maybe I'm wrong, maybe it is. But mostly it has to do with me recognizing infinite types and handling them internally.
Well, I mean, the simple thing is that you can type without infinite types. You can type the omega as the self-application term as using an intersection type. It's like, what is it? I think it's like alpha intersect alpha to beta to beta. That's, I think it's how it.
That's okay. Yeah, I have to look at it, but it sounds sort of correct. We'd have to understand what intersection means per se.
Yeah, intersection means that it can be typed with both of the typings.
Okay, fine. As opposed to union, fine. Yes.
But there's
Intersection
a-
meaning both left
there's-
and right.
There's an intersecting, so it's a good question, Cliff, because like we use the or operator to do intersections. So we say A or B, right? So we have two types, A or B. And so we know that no matter what's in that reference, the referent is going to be an A or a B, right? But there's two different uses of that information. One is if I try to call foo, the compiler has to check that there's foo in both A and B. So that's the true setwise intersection, if you will, that
Yeah.
you would expect. But it also, as you know, in Venn diagram sense, it is the potential area that such a type corresponds to is actually the kind of those two circles, right, that just have that small overlap. But the thing is, just because the set of overlap is, say, just foo and bar, it doesn't mean that anything that has a foo and a bar is that intersection type, right? It still has to be an A or a B, unless you apply duck typing to intersection.
No, right. No. Right. So I do nominative structural typing. And if you demand an A and a B, then you, oh, that's a good point. I can demand an A, which will have a foo. I can demand a B. I'd have to have a type which is the parent of A and B to accept both A's and B's.
My hunch is that the intersection is like an escape hatch. If you are Hindley milner, you have to unify. But if you support intersection type, you can say it's either this or this without unifying them,
Right.
because intersection type is a types on its own. That's the trick, at least to me.
So actually, we're renaming, that's the link I stuck in the page. We're renaming our intersection type to the either type because of all the confusion around the words and type theory.
Oh, yeah, right.
When you say
So basi-
either, it makes me think it's a union, not an intersection.
Oh, okay. You should read the link. So because union is another one that's totally fucked up in the terminology.
Yeah.
Because and I show that in that bottom paragraph in the page I quote from Wikipedia, where basically they say a union is either of, and then it also says the union are operations that are valid on both types. So it's like, okay, make up your fucking mind. Like there's no, and by the way, union types are also known as sum types, which is like,
Yeah.
so they're not really thinking about the types. They're thinking about like
They're-
first derivation of types. anyway.
There is a theory behind the sum and the product types. I will find it and throw it next time. There's the gist of it, because I don't remember it exactly. One is how the type it's can possibly be. This is why intersection. I will find it because I won't be able to say it right now for the next time.
I spent a few hours this week reading through a few hundred pages of stuff on this. So get this. Sum type is also known as tagged union, is also known as disjoint union, is also known as discriminated union.
Yeah.
Right.
So we have four
That sounds
terms
about
for the
right.
same one thing. And it's like, oh man.
And I would claim that a discriminating union is sort of morally equivalent to a standard Java style subclassing operation, where the tag is user written and more explicit, but the union comes underneath just means you're a subclass
Right.
from the basic union.
And what I'd say is the term subclass is kind of a more specialized form of a general concept, which says, you know, types having a greater than, less than, equal relationship to each other. Anyway, yeah.
Mm.
But
Yeah.
yeah, the terminology.
We
the
agree to be fuzzy
terminology is
here.
just- that's the problem, is most of the terms are fuzzy, then they end up getting picked up and misused by a language, and then
Yeah. Next person is fuzzy the other direction, and now you're all confused.
yes.
So what's going on with this other code block, which somebody says?
Yeah, so
I-
that's my question of, do you get a proliferation? You said that each call site gets split. Do I end up with 32 eyes? Do I end up with one eye that has an OR type in there?
Oh, what is the type of?
What is the type of eye?
I is a function from whatever, and then yeah. So
Because I have my
this is-
split and then it runs down, and I don't know whether each of those functions is going to get duplicated or.
So what's the if is your final result? Okay, this isn't. It has to be rewritten to be legal code, and then I'll just run it. And that's because you have a forward reference.
Right.
So
It seems to be an off by one error here somewhere,
yes.
because n is not defined.
Yeah, where
N is missing.
yeah, define in.
I think he was thinking the other way, that he'd throw n in and then it would percolate up. So that's what I meant by off by one. It's like,
I mean, you can right. You can define in by making a function which takes an in, and that's
hey,
Okay,
And
so I
then-
need to reverse the order of my list of functions.
yes,
Right.
that's two, but you need to define in as well, which you can do by wrapping everything in a function which takes an in.
I think he did with the I at the bottom. I think he meant n. Did I
Oh,
misunderstand?
now
that,
you
or-
put I there. Okay, you're busy reversing your function list now.
Let's see.
I'll let you hack for a minute and reverse things. And then I think we'll have a well understood situation. And P is just a random predicate, which we can also pass in as a function argument. What do we got here? I is, yeah. You're declaring I to be the identity function. Fix your syntax. Okay. I is an identity. K uses J, which isn't defined. L uses K, M uses L,
Okay.
N uses M, if
see.
pred, so it's I, okay. Now we still need a pred, but then we can just do that in a second here. I'll let you do your thing. So the next thing is that the application syntax is not what you've done. It's classic lambda calculus syntax. Somebody busy adding, oh no, okay, new line showed up for, why is J in here now? No one's using J, why are you defining J?
They were.
Okay, and now I need a definition for pred, which I'm gonna throw in here.
Right, for pred, I just want something that it doesn't already know what the pred means.
Right.
Hmm.
This is one way to do it. Well, here's another way to do it. Hang on, I can do this a little easier. I have a function random, which is specifically for doing this kind of stuff here. So I would get rid of this actually and just do this.
Random is just thing you don't know what it's going to do.
Yeah, it
Mhm.
returns me number from 0 or not the 0 exactly. So if tests go arbitrarily, I need semicolons here because this is syntactically sugar for let I equals blah, blah, blah in, that's the semicolon in the remaining expression. So this is identically equal to let yada, yada, variable equals yada, yada in body.
I don't know,
Um,
Cliff, that extra semicolon, I may have to give up on AA.
Yeah, I know. Sorry, I needed to know white space to line terminates, so, or what to expression terminate.
You know,
Otherwise,
I'm
you
teasing
are
you, right?
ambiguous. You need something there.
So how we would type this? I believe it's
Yeah, let
The-
me go throw this into the land of Emacs and see if I can get a type on it here.
the fact that the functions are called. I don't believe it would be hard to type it.
Yeah, I expect it to work. The thing I don't understand is how many eyes will there be at the bottom as you're trying to disambiguate call sites? Am I going to get an
well, only
exponential
one.
number of eyes, or am I going to get like,
No, you get one. Let me have to outquote your variable A, your string A. And then I probably mistyped some other stuff here, so I'm off.
That's a good point, Cliff. We should make sure in any lecture that's being built today to accept all the weird quotes. So when they paste it into Word and then paste it into the code, it still works.
Oh, yeah, I'm in the zone of I'm not sure what to do with weird quotes yet. I have issues. Oh, okay, so I'm going to get a type here. I need to actually put a type in to parse for the correct answer. Wrong type in, so I won't get to the second round because it's going to blow out. It says in scalar. That's actually probably correct. Let me.
was it
Yeah, that's
Kotlin
correct.
that let you use all the weird quotes? It may have been Swift.
I
know there was one language that if you had the open quote specifically and there were more open quotes in the middle and then close quotes on the end, it would check that your open quotes and close quotes were balanced. You're like,
Interesting.
they were like, it makes it easier to put strings in strings if your quotes are parentheses. And I was like, does it though?
The triple quotes are easy.
And also ugly.
Be it ugly, I would stick with triple quotes.
I'll have an
There's always
interesting.
Markdown, which uses 4 white spaces on your left margin to mean.
Well, that's problematic.
So yeah, I'm curious what the numbers are in the output of that.
Oh, I have an extra star.
Quite how many memory locations are there?
For the I,
Oh, I mistyped my result here. One more time. Oh, look at this. Okay. So I can type this thing.
You want to drop the result in the doc?
Yeah, well, I am getting an inconsistent result, which means I don't have the bugs out. So let me show you the result that I have. And then I got a second result when I tried a different time, which means I haven't got normalization correct. But almost surely the one I'm going to drop, I think the one I'm going to drop is going to be probably the result that you'd expect. So there's the expression followed by, flow typing says in scalar, it's a mix of 1 and a string. And Hindley Milner says you are trying to unify ones and strings, and that's not allowed in some contexts. It's then being used somehow in a way that I have to tell 1 and string and I can't. So I'm
But this does
disallowing-
work if you just use the identity.
I'm sorry, what now?
If instead of n being this long chain, n had just been the identity, this would type correctly.
This would drop to scalar, I believe.
Yeah, at some point, so this is the question of whether or not you're finding bugs in me. This is the right way to do this. I'm kind of expecting him to claim, since I'm not doing shit with it, oh, he's returning the results.
This should drop to any equivalent in the
Yeah,
type
he
system.
can't. He can't.
Ultimately, n should have the same signature as the identity function. It takes a thing, it returns the same thing.
Yeah, I'm not telling you what n is because you didn't ask for n as the final result.
Here is a pretty much convoluted way to an identity function.
Yeah, right. So you could ask for what n is without doing the if rand yada yada. Here, I'll do that at the bottom here. I'm just going to ask what n is instead of if rand of n of this. And that'll tell me the type of n. And I have to do it in, okay, so yeah. My assertion's too strong because of course I changed the flow type and I'm testing it first. So I don't get the Hindley milner type because he
Okay,
blows
the
out because he expects an n scalar and he actually gets a function back because n is a function. So let me go force it
The
here.
first line, this should be A to I type.
Okay, so yes. So he in fact types in as a function from A to A, which means he probably should be able to
I
type
was going to
it.
say, if you can type it as a function from A to A,
Yeah, right.
I would think
This-
that the if would just return int or string.
But we don't have intersection. type.
No, but he goes to the intersection type. Well, he goes to the meet type in the lattice, which would give you a, oh, that's why I didn't do it there.
This is
No, my
an-
Hindley milner will tell you I'm not going to allow,
we don't have intersection type yet.
so if you are passing it through only and then do something with it, pass through, no one escapes, and I'm okay with that. If you hand it out to the outside world, I have to tell you whether you got an int or a string, and Hindley milner doesn't have a thing which is int or string. Classic Hindley milner, I'm not talking about intersection types. Classic Hindley milner doesn't have an int or string. The flow type has an int or string, that's in scalar. Scalar or in scalar, whether null is involved or not, but yeah, I have a type for that in the flow system. Hindley milner does not have a type for it. So it can't be in the output result.
Mhm.
And that's the issue. If it's passed through, if Hindley milner knows he doesn't know, but it's only passed along, he'll let you just pass it along. And then at the point where you passed along, some other piece of Hindley milner has lifted it to the int or the string at each different application site. Then he knows here it's an int and here it's a string. And I didn't care that I didn't know what it was in the middle. But if you pass it to the outside world, my type has to tell the outside world, what is this Hindley milner type? Well, I don't have an int or string in Hindley milner. That's not a standard Hindley milner presentation.
What if I
Oh.
then pass it through something like print that could take the int or could take the string? Either way, it would be happy.
Yeah, if I had a function of Hindley milner style, which would take an arbitrarily typed thing, and I don't, because I don't have any way to type it in Hindley milner. If I put it through what's the right way to lift it? You have to know, you have to start from a place where you know what it is. So the application of n of 1 returns me the 1 buried in some other context, but the 1 is well known when it's returned. So if n was not an identity call, but instead took the argument it was given and squirreled it away deep inside some other type, I would still know that you had a 1 squirreled away on the inside of this thing. Because it's just a pass through, but it buried it inside somewhere, but it didn't change the 1. Like it didn't apply decrement to a 1. So then if you hand a string in and I squirrel inside somewhere, that's fine. And I can handle that. And I hand you back a thing with string squirreled inside. But again, you shouldn't try to decrement a string. So that's sort of the difference here. If the end result comes back out to the outside world directly, the outside world has to have a type for it. And I don't have a type in Hindley Milner for int or string, other than the error type, by the way, is the type for int or string.
For the matter of discussion, if we go to the reverse way, the float type should be able to narrow the type to figure out what is being passed. So instead here to be int 8 or a string, we pass a scalar. And the result is scalar, but later on the use side, you pass it int or a string. The float type, I believe, should be able to figure out to narrow from the more generic type to the more specific type.
Okay, the flow type doesn't get a more specific type directly. He gets it from Hindley Milner. This is where flow and Hindley Milner shake hands and pass information back and forth.
So if I being another function, here is if I will copy it here. If I would be yet another function, but here the arguments are not into a string, are just scalar. That the equivalent of any. And later I use it either with a string or I use it with an int or a string or an int. Should this be still a scalar, or should the type narrow it down to an integer or a string?
So here you're using the same I, and because you're using I'm sorry, if I is defined in a let, you get a fresh copy of I in either case, and he can sharpen it. And if you use I from an argument on a lambda, it has to be the same type in both places, and he cannot sharpen it. And he will not, Hindley Milner will not sharpen it. If Hindley Milner sharpens it, he'll sharpen it for flow, who will then proceed to take and run with the sharpened type.
Okay.
So that's sort of the difference. The let argument says this thing is now polymorphic in every use case. And that's when I say let, it's the same as saying the equal sign. I equals, that's let I equals. Then it's polymorphic in every use. If you have a lambda, so the lambda x arrow x, as soon as you say lambda x, x is not polymorphic in use, in which case it has to be the same type. If it takes both a 3 and a string, it has to take a scalar in, a non-zero scalar.
So I have my if statement, which is going to give me something that's either an integer or a string.
It would drop to a scalar immediately.
If I assume
because
that there is a toString on integers, and I assume that there's a toString on strings, that just gives you the string back.
So
I feel like this if that is then passed to toString should unify if int and string are both structs that have toString on them.
Exactly. So in the pure lambda calculus, an int I is exactly what you think it is. It's an int I. Okay, in AA, I'm printing ints as a nice looking integer. Internally, they are totally represented as a struct, which has the magic 1 or 17 somewhere in it, plus all other fields representing functions you can call against ints, including toString. So it's a struct which has, amongst other things, a toString as one of its fields. Strings have a toString as one of their fields. The end result is a struct which has a toString, is required to have a toString, which both do. So AA will type this, whereas I'm going to say the sort of classic lambda calculus blows up and says, you're mixing ints and strings and you get an intersection type, which I print as cannot unify int1 and string A, but that's an intersection type for all intents and purposes. Having thought about it while we were just yakking, my error types are really an ordered, canonical, consistent, repeatable, same error every time. They're actually an intersection type. I know you want to be both an int1 and a string in all contexts, and I don't know how to describe that in Hindley Milner, but that's I know what you're trying to do here.
So does cannot unify int and string have a toString method on it?
Right now it doesn't, and that would be an intersection type for Hindley Milner. So I'd have to expand my type system to say the intersection type exists, it is not an error, and then I don't know what happens to it after that. Like the real problem here is that I have to have properly functioning intersection types. And I kind of took shortcuts on the intersection type because I wasn't expecting to do anything except accumulate with them. They also have an impact on runtime because they require you to check all ways in a bunch of places, which I'm slimily doing now by claiming if you have multiple ints coming in and multiple floats and multiple strings and multiple pointers and multiple blah, blah, blahs, the ints all meet in the lattice with ints, the floats all meet with the lattice and floats, the pointers and the functions all meet in the lattice with pointers and functions as according. And then I end up with 4 primitives. And that's my intersection type that I end up with. That's the level of precision I get out of the intersection type. And then right now I just say cannot unify and I walk away from it, as opposed to saying I'm going to pretty print you as a 1 vertical bar as an intersection type or an and or however you do it, print it string. And that's what Hindley Milner knows about it. I'm currently of the theory that this type leads to some bizarre typing things that are non-obvious. And maybe, maybe Cameron will tell me I'm wrong. I do want to support that. But at the moment I'm thinking it leads to types that are not obvious what the hell the type is or where it came from. And so I'd rather say, no, you can't type this. I definitely want to allow tagged unions, and I'm going to allow them because I'm going to allow classical subtyping. I believe it's always classical subtyping. And you won't be able to tell them apart. The difference, it makes no difference. There'll be some syntax difference, but the actual what's typed, what's valid, and what's not won't change at all.
So tagged union is basically our implementation of an intersection.
Yes. And now the question is, if I just pretty printed your tagged union as Java classes with subclasses, is there something that semantically can be done with one and not the other? Are they effectively the same modular syntax?
Ask it again.
Okay, suppose you have a tagged union where the tag says, I'm a person and I have a name, or I'm a dog and I have a count of legs or something stupid. I don't care what, I have a fur color. And I have to check the tag, and having checked the tag, I can now ask the person's name, or if a dog, I can ask his fur color.
Yeah, so we don't have a visible tag. It's an implementation detail that we may or may not stick in if we need it.
So,
Right.
So if you're a Java subclass, you have no visible tag. There is a parent, which is the name of the whole enum or the whole tagged discriminating union. And then he has 2 implementations, one person which has a name field, one dog which has a fur color field.
My question here is that
no, and I don't understand why that's a no.
do you have to define the tag union prior to using it in a function? It has to be a dog or a cat, and
Right.
you use this tag union or a dog or the cat, because that's the difference. I believe if you have to define it, the intersection type is a type on its own. You can construct it without defining it prior.
Right. Okay. So I would claim those are syntactic choices. Like if I have to define it up front or not, I'm going to type inference. So I'll get it from the inference or not, but I could define it up front.
So in our case, to just syntactic, well,
So
type
throw into
rules.
the code, throw into the doc a code block, keep it as short as you can, and whoever said the n2 string and n+1 string, that will type in AA where both ints and strings will happily have 2 strings. But not in the bare land of calculus necessarily, where n is something that has to have a 2 string has to be struct the 2 string, and n+1 is an integer, and you added 1 to a struct, and that's not allowed.
But
So-
something, okay, I will come back here. I have a question to ask. Go ahead, Cameron.
So here you're predefining a tagged union int or string.
Right, so this would be like a method, right?
Mhm.
And
It has a method foo.
So I could return here.
Oh, you're returning a tagged union from foo. I see. Yes.
No, the return type from foo is a tagged union.
That's
but
what I
we
meant.
never-
You're returning a tagged union from foo.
Right,
Yeah.
but a tagged union can't exist. So nothing ever has a type of tagged union.
Oh, in ecstasy, nothing has a type of tagged union.
Right, so
Yeah.
we can return an int or we
Yep.
can return a string, but there's no object that's an int or string.
Gotcha.
So it's a middle, right? At the ends, you only have reality, and in the middle, you can have anything, but they're
Yeah.
There are more constraints than any.
So I would claim this is extremely close to me coming up with a Java style class that was interstring as its name, and it has either ints or strings, and the Java class is abstract. You can't make an instance of it, but I can carry through an interstring everywhere. And then at some point where you end up using it, you have to discriminate you're the int version or the string version. Like morally, I'm going to claim, I'm going to type underneath you here, moral equivalent here if I can do this.
Sure.
And you can tell me I'm incorrect, by the way, I might be wrong. Let me try to get a little more closer to Java syntax here. And you don't even have any things on it here. So then I have some other int, extends int or string, and it has a field int.
Right. So you're creating a hierarchy to represent.
Yeah. But I'm saying that the hierarchy can be totally under the hood. You never see it. I just magically did it. Like if your int or string is typed this way, when you actually do an implementation and you return an int or a string, somebody has to tell that string needs garbage collection or not. So you have to have some runtime info on there that lets you tell that somebody returned me a 17 bajillion or somebody returned me a pointer that looks like a 17 bajillion, but it's actually a string pointer. So you need another bit in your implementation to tell them apart. That's the tag. Maybe it's just one bit, maybe it's just the location, something, there's things going on, but you need that one bit somewhere.
That's because this version has to propagate to a runtime, and you have to check. You are forced to check what are you dealing with. This will point to an instance if check. I believe that's what you.
Yeah,
wrote.
if somebody, my version allows an instance of check.
The Cameron union only participate in the type system, as I understand it. You cannot construct something at runtime.
Now use the result somewhere. I got an interstring out of foo. I put it in a variable. I passed it along in a variable for a while. Later on, I want to use it. Do I have an int or do I string? How do I tell? Somewhere I do an instance of on it.
How would this function foo materialize at runtime?
Yeah, you made an A. Now screw around for a while and then ask a question about A. Well, I can add one if A is an int, and I can grab the first character if A is a string, or ask for the string length if A is a string, but I can't ask for the length of an int, and I can't add one to a string. So I have to tell them apart at the use. Somebody answers the question, what the hell is it? So console print is a dangerous thing because it secretly hides under the hood. He asks that very question. Am I looking at an int or a string? So don't do console print. Do an is test or an is of or an instance of.
No, that's why I did the console print first, was to show exactly. Okay.
The problem is that console print hides within it that instance of test. Show me the instance of test. Then you can implement console string using your instance of test. That's great. So you have an instance of test. Okay, perfect. Now stop right there.
We get to a runtime representation of the union.
Somewhere you answered the question, I got an int or a string, and you could tell them apart. And I'm claiming that my version also can tell them apart. And that was the key aspect of it. And so far, I haven't seen anything that makes one different from the other. Now, in the Java version, I had a whole fucking Java class hierarchy, and I had a whole fucking V table, and I had an extra layer of indirection for the int. And you don't need that shit, but you need the bit that says they're apart. One's an int and one's not an int. And where is that bit? And the fact that you have the bit means that morally these two are the same. Like if I disallow the Java version from you asking get class or whatever other random stupid things, you can't lock it or hash it or shit like that. The abstract class, I mean. If I throw all those features away and I just trim it down to what you saw, what we're talking about, I claim it's the same as a tagged union.
At runtime, they are the same thing, at least.
Well, that's. I mean, what set of things can you do to one or the other? I claim they're the same set of things.
Yeah.
And therefore, a tagged union in my head is a version of a class-like thing with an abstract parent. And
we don't use the term tagged union because it's an implementation detail.
Yeah, fine.
If I were writing in C, I'd use the term tagged union because that's what it's called.
Yeah, that's how you expect to implement it in C. No, in your int or string, what do you call that type?
That's an intersection type.
Okay, so, but I thought you're busy changing the name from intersection type to something else.
Well,
either.
now we call it an either type because other
Yeah.
people use the word intersection type to mean something completely.
Yeah, so I claim I
Hmm.
have an either type with my Java class Schmidt. That's the same semantic, has the same semantic behaviors.
At runtime would be the same thing. It would mean the same thing because you have to disambiguate what are we dealing with.
Yeah.
So that's an intersection type.
Yeah, and well, all I'm really trying to say here
Sorry.
is that intersection types done this way, or maybe either types done this way, have no new typing issues to solve over a subclassing like behavior.
Okay, the one trick the intersection type could be because if the at compile time can figure out what you're dealing with, it can just fall apart and make only the int version of it.
Yeah,
or the string version of it. But if
same
you're
as
not,
the same on the subclass. Like if I seal the abstract class, if I seal
Okay.
it, he only has two
Mhm.
subclasses. If I test the one, I know it has to be the other.
but you're okay, but you're force it again to test at runtime because
You
but
must test at least one at runtime. Yes.
Yeah.
So
Yeah. That's the- that's the
in the realm of AA doing flow analysis, sometimes I can track through
Yeah.
and for free know that you don't have to cast it.
for sure you can figure out that you can test only once what you're dealing with and specialize the code or some magic to erase that checking again. Like only magic I can see here happening with the intersection type is if the compiler can figure out at compile time which type it has, it can only emit the version for the int or the string, not the both.
Well, I'm
individual
talking
check.
types, not optimized compile versions.
So
Yeah.
just so you know, the console print line doesn't do any check as to what the type is. It simply
Mhm.
calls toString.
But
Okay,
you have
and
to.
how does toString on an integer work?
It has to
that's
have
How
the
do
a
you make a
It's-
function called a toString where the function is an integer?
You make a method call on the integer object.
Okay, so you reverse the integer and you've put it in as an argument to some function, and now you have to do dispatch. So how did you figure out which toString you're talking about?
Well, it depends if you're thinking in terms of conceptual how it works versus implementation how it works. I mean, implementation how it works, I want it to work like I'd write it in C. Conceptual how it works, I want to pretend that everything's an object.
Okay,
so
that's the Java answer. The
No,
object has
that's
to
not the
string.
Java answer.
yeah, it's not Java
Well,
answering.
Why?
Yeah, now I'm still trying to figure out where you did dispatch to figure out which function to call, which means dispatch here means
Worst-
I had to be able to tell between an int and a pointer to a string. How the
So
hell did
worst-
that disambiguation
worst-
happen?
Worst case scenario, my first pass JIT is going to take interstring and make it basically the equivalent of Java object. right?
Okay, perfect.
Because
That's
first
the answer I'm
pass,
looking for.
first pass, I don't care how slow it is. I'll do instance of it if I have
Yeah.
to, whatever. Boxing is not that
So
scary.
right. So the answer semantically is you're going to wrap an int.
Right, unless I can, for my first pass JIT, unless
Yeah.
I can prove
Right.
that what I'm dealing with is an int,
Okay.
I'm
So
going to wrap it.
yeah, so we're confusing optimization and typing. And I'm trying to break that apart. There's an optimization which says most of the time
Yeah.
I can tell what the fuck's going on. I'm going to get
But
rid of the wrap.
that's why I said there's a conceptual how it works. The conceptual is that we only have objects. So
Yeah.
So
Okay.
one is an object. In fact, one is here is not an int. It's actually an int literal, but because I can only return an int, this will get at compile time, I'll do the conversion, constant folding, if you will. I'll do the conversion from the int literal one to the int one, right? And this is a string, so a string is a string, so that's fine, right? But we couldn't do something like this. Given an A, do something, a dot foo, and so just any A, I don't know what it is. Whatever. ToString size greater than 4, right? So some basically random, right? So given some A that I have no idea what it is, but because it's an object that has toString, I could return either 1 or hello. This would not compile because intersection type is not allowed to be inferred. And that's a syntactic rule. Well, type system rule. We choose not to infer an intersection type because 99% of the time it's a bug.
Okay, so-
It's a
That's
it's a
fine.
source code error.
And you get
If
an
you're-
error that says, add this annotation and we'll be happy.
Oh, yeah.
If you
Exactly.
add, if you force it, you emit the, yeah.
Okay, I'm sorry. The error here is like quit with the returning int or string. The question we're trying to answer here is A supports a two string or does not.
The magic.
Yeah.
here-
All A's support two string because
So everything in the system supports two string, including the integer 17, the value pi.
correct.
Okay, so they all have this object flavor to it. And then you hope the optimizer clears it out.
So-
Yeah. So exactly. So I mean, object is an interface, not a class. But let me see. Object has two methods: toString and make immutable.
Yeah. So what had happened is that object is the runtime representation of a top level. It has the method you are calling it.
Right,
That's
right.
that's why you are allowed to use it, because the object it's the top of the hierarchy, and if you call it to string either on the left side or on the right side, that's
Yeah,
why
it's not a strict hierarchy. But what you can say is that there is no reference. You can't have a reference that you can't call toString on, because every reference is to an object.
Mhm.
Right. Now I can know more about it than that it's just an object, but no matter what I try to take away from the type, I can't take away object.
So the short version is this is a type, but if you cannot type it, it has to be an object. If you can figure out what it is, you can eliminate the intersection type. And
You're kind of thinking from Java terms, because basically we never ever use the word object
okay,
in our code. Like
okay.
I think we use it a couple times in serialization,
Mhm.
but basically we never type object.
Mm.
Like it's idiotic to have a type called object other than to have it, right?
Okay.
Like, so because you would always use, the reason you have to use object in Java is because you lose your types. Right?
Mhm, yeah.
So you
Yeah.
have to have everywhere.
That's-
You have to come up with some type that represents it, and that's always going to be object.
That object is the runtime representation of any. It can be anything, but it's a runtime object and it has some methods. on it.
Right, but very rarely in code would you ever have an any. Like,
Yes.
where do you have an any?
Failure
I mean,
inference.
yeah,
Unifying
right.
unifying int and string. It's an any. For here.
No. Unifying int and string is an int and string.
Well, if you have an intersection type, you get the
Intersection.
unification that way.
Unifying. I
Right.
said it's.
But in our case, when we do this, we get a type that is int or string, and that's the
Mhm.
type.
Yeah.
And so
Does-
we try to think in terms of, in terms of countables, right? There's ones, there's tens, and there's infinities, right? I don't know. Pick 3 bins, small, medium, large, right?
Okay. Yeah.
Like when you're optimizing for garbage collection, for example, you don't worry when you have, let's say everything's the same size. You got 3 different classes, A, B, and C. You don't worry about the A because there's 14 of them in your whole system. You don't worry about the B because there's 6,000 of them. And the C, there's 12 billion, and that's where you spend your time optimizing. 'Cause saving a byte on the A or B doesn't make any impact in the size of the running system. But saving a byte on C, you get H2O at the other side of it, right? Like it makes a fundamental difference to be able to compress your big O. So for us, types are in that middle category. We know that the number of types isn't, it is not in the range of 1 to 10. It's more in the range of, give me a second, Gene, how many types do we have in a running system? Type instances. Yeah, I mean,
And I've certainly
Hundreds.
seen Java systems with
hundreds
tens
of
of thousands
thousands.
of classes.
Big Java programs will have tens of thousands and not necessarily 100,000.
Right.
of classes.
And that seems reasonable. Right. And so we don't mind having one for each, even though in theory, you could build a program that tortures the type system by creating a billion, in theory.
Mhm.
That's sort of a, okay, I think we maybe lost the thread here. Because I was trying to sort out that I could do intersection types as if they were subclassing or even just as not the other way around. They claim that they're the same, two different faces of the same concept. And you can look at them left or look at them right, and it comes out the same. And in
At
particular,
runtime. Yeah.
inferencing logic doesn't need to have anything different between the two. So my type inference algorithm doesn't change if I do or do not support intersection types, as long as I'm already supporting subclassing, however that's done. And it turns out that I am, because I have row polymorphism, which covers subclassing already.
Right. In a lattice, I think you could take any arbitrary 2 points and create a point immediately above it. That would be your super. Yeah,
Yeah.
sure. I think that even though I'm not an expert on lattices, I've seen the pictures.
So two different concepts here, though. Row polymorphism handles subclassing. The lattice will take any 2 points, it's closed, any 2 points, and make a new point that's in the lattice.
Right,
And that in particular means that all intersections have a well-defined point in the lattice, but sometimes that information point loses knowledge. So the intersection or the meet of int and string turns into scalar, and that lost knowledge.
Yeah. But the scalar, what is the runtime representation of scalar?
A single register.
So it's a kind of an object, kind of something.
Yeah, but it doesn't carry any type information, whether you're an int or a string.
That's the main point. One is the type level, the other is how these types materialize at runtime.
The Hindley Milner guy knows something about int or string in that way.
Yeah.
So what I get out of flow is different from what I got out of Hindley Milner. The two are not, one supersedes the other, they have different knowledge.
Yeah.
And what I've been doing is feeding one into the other back and forth to get a better answer than either alone.
So there's,
Sorry,
what's that?
How do you deal with enums in your lattice?
An enum is a subclass thing. It's an either type from Cameron's point of view or an intersection type.
So if I have two enums that share a number or a string,
If you have two enums and you're using nominative typing, they are different and they cannot share. So I have an enum of Persians and I have an enum of trees.
right? So I could have a nominative enum, or I could just have an enum that's a set of values.
Yeah,
So you
secretly
treat those
under the
differently.
hood, that set of values gets a type that has something, and there's a tree structure involved there. The same set of guys can be numerically equal, but you would have to change their type transitioning between the Persian enum and the tree enum. And yeah, I just lost your set. You're muted.
Even two anonymous enums are considered to be distinct from each other.
Yeah. That's how I'm currently viewing it. Now we can argue that there's a way to do this some other way where there's overlapping, but right now I'm thinking if you have overlapped shared internal parts, that there'll be a hierarchy that has to have an equivalence class tree-like breakdown. And there'll be something that's in both and something that's in the left guy and something that's in the right guy.
Yeah,
And
so if
all
you
the-
scroll down a little, I was doing a weekdays thing.
Okay,
Where it's like, I've got my weekdays and I've got my weekends and I've got
Yeah.
Friday, which I consider to be both a weekday and a weekend.
yeah. Yeah,
It-
that would be.
There is some
a-
logic in defining this is weekday and weekend. That's
Yeah.
only Friday
This
or
would be,
weekday
there's a
or
super
weekend.
class, there's a super class enum that covers both of those. And then weekday is a subset of the superclass and weekend is a subset of the superclass.
Okay,
and then
so I would
they share it
structure by declaring weekdays and then declaring subclasses of weekday, I could get this behavior in your lattice.
Right. Now, whether or not you declare it or I declare it on your behalf under the hood, you never see it happen, but it happened anyhow, doesn't sort of matter. It's unrelated. So I'm saying there's a syntax or not, we can choose that, we can fight it out, but
Okay,
ignoring the syntax, what the typing system is going to do under the hood, what I would claim the typing system to do to get a good, strongly well-typed, easy to analyze, works, all the algorithms work, is say, there is a super type. You don't see it in this case. It's anonymous. It has all of Mondays through Sundays and Fridays and everything in between. And then weekday is a subslice of it, and weekend is a subslice of it.
Okay. So it'll make some kind of point where the two meet or join. I'm not
In
sure which
order to
direction I'm
have a
going.
shared common Friday. Yeah.
Okay, so weekday and weekday or weekend will just be a difference of the meet or the join of those two.
Yeah. Yeah, that's a separate, yeah, right.
And weekday plus weekend, I need to make some kind of discriminated union.
Yes. Right, because when Friday rolls around, you mean weekend Friday or weekday Friday? Yeah, exactly.
Okay, I think it makes sense. I'm not sure what the ideal syntax is to express these things, but
Not me either. In particular, you use Friday inside two different scopes. So I claim they're two different Fridays. And therefore, these would be two different enums that are not related in any way, and they don't actually share Friday. Because they're
What
two
would
different
be-
Fridays.
yes, I would have to have already defined Friday
Yeah, you have to define
outside of
Friday
the scope
first.
of either enum.
Yeah. Yeah.
What would
That's not a
they,
bad way to say to express this, to say, look, if what you actually want is all 7 of these things, do a let for all 7 of them, and then make enum 1 and then make enum 2. And because they're shared scope,
Yeah.
they exist. Like,
Yeah. Yeah.
that's not a crazy way to use the scoping as the way to express that.
Yeah. And then somebody has another version of weekend where you just have a Boolean also tag thrown on all the enums that you decide weekend or not. But that's an implementation strategy that's very different. That's a reasonable implementation strategy if your goal is to distinguish weekends from weekdays in an easy way. But the goal, I think, for Aaron was to present 2 different tag unions that had no shared overlap. And what the hell does the type system do with it?
what would they be at runtime?
And change weekend and weekday for cards with spades and clubs or something. And I don't know what you do for
See,
your
I'm not sure
overlap.
where the tagged, I'm not sure where the tagged union came into that though.
Well, when I
The
look at
tagged
it,
union is the sum type as distinct from the union,
yeah,
which is or.
I came through with weekday and I picked a hidden secret tag that has 4 bits that gives me a number for Monday through Friday, or 3 bits or however I need. And I did the same thing for weekend. Oh, but they share Friday. And you forcibly told me they must share Friday. So now I need a tag set that has something unique for them both that they can share on the Friday, but their other bits are unrelated. But life becomes a lot easier if I declare them all to be parallel unrelated. So the tag numbers for Monday, Tuesday, Wednesday, Thursday do not intersect with Saturday and Sunday, even though from the type system point of view, they're no relation, and I could just reuse. I could use 2 bits for weekend, and Friday is the 0, bit. And,
Yeah, you can reuse, but if you cannot reuse, life is better.
Yeah, yeah. So the implementation wise, and in the typing system, it becomes easier then to say, I don't do intersections or tags or this way, whatever. I do a subclass like thing. Therefore, Monday through Saturday are all in the same bigger subclass. Now I do something with them both from the type system and for the implementation where I 3 bits and I have to 3-bit it. Fine.
But you might want to do that also for the tagged union and say, rather than storing a tag bit and the other thing, I'm just going to multiply them together and say, okay, here's.
Anytime you have a tag union that shares parts that has with another tag union, I'm going to claim them to be part of the same parent. So Ziglang does this game where they do error codes, and they want to have enums of listing certain kinds of error nodes out of the Linux kernel. But the error nodes have already, by the Linux kernel folks, been unified across the whole kernel space, and they're all different. But if I have the return error codes that come out of file operations versus the return error codes that come out of malloc operations or sys get memory or whatever the hell, they're very different, but they typically don't overlap, but they could. There's a couple things that could overlap in there. So, you know, Ziglang does a nice job of saying these all are known to be dependent or independent. But if you group them together in a larger set, we know they have to be independent across the larger set. All the different enums are now in some bigger and bigger set. And so he does just exactly what I said to you here. He says, I'm going to take all of them that you're going to use, throw them in the same big bucket, give them all unique numbers, and then you can slice out whatever buckets you want to say, this is the weekends, includes Friday, this is the weekdays, includes Friday, this is file close, includes a general IO,
That's
IO
more a
error.
dependent,
This is,
that's more a dependent type system though, wouldn't you say? Like,
no, it's nothing to do with dependent types. This is just,
Yeah, where each function returns a subset of the domain.
yeah, it's not a dependent type.
That is a dependent type.
Okay, I don't understand what dependent types mean, because as far as I know, that's not a dependent type. I just said
Well-
you've declared a subset of a domain. That's a,
Yeah, like if I have a int domain that's 0 to 4 billion, for sake of
Mhm.
argument,
right.
in a dependent type system, I could say, well, this function returns 0 to 100. That's
Okay,
a
I would have
dependent type.
said, Theodore tells me something different about what dependent types mean. You
Hmm.
just subclass.
We have to agree. No, how should I say it? The Cameron definition does two counts for a dependent type. As I understand Cameron said, if you have the number 1, that should represent the range for 1 to 10. If you have the number 50, that should represent some other kind of range. Is that what you're saying, Cameron, or something like that?
Yeah, basically, any subset selection out of a type's domain defines
Yeah, but
defines a dependent type.
Yeah, but that subsection should depend on something. That
Right,
can
it
be the same type, so for each range of integers, but that can be also unrelated type. That should also be viewable. The dependent type should only defines a new type based on some other type.
Right,
That's
it's
dependent.
based on int.
Okay.
So,
Okay.
So like odd numbers, that's a dependent type on int.
Okay. Yeah. That's correct.
And 0 to 100 is a dependent type on int.
Yeah.
Well, what I guess I'm worried about is using the word dependent types in a way that's not what the standard lingo means for dependent types,
Hmm.
as opposed to just taking subselections of a parent set of types. So I certainly handle subselections of ints all the time.
At least
That's
in my
fine.
book. In my book, a dependent types means a type that depends on a value. That's what it means on type. It can be the same type for each an
Depends
integer.
on some value that you got from somebody. Well, that gets into the
Yeah.
whole, how the hell do you,
That's what dependent types, at least to me, means.
you can't do inferencing in reasonable time frame or time periods.
That's where it gets complicated in the dependent type
Whereas
system.
the standard subselection types that Cameron was just talking about,
Yeah.
I can do inferencing in constant time or
Yeah.
linear time.
Yeah.
That's not an issue. But
Okay.
the input value to a function doesn't change its type. That's what I understood.
That's what dependent type means. The value influence the type.
Yeah, and that's what I'm saying is not a case here.
Mm.
Yeah, somebody's busy writing discriminating union things, and the discriminating union comment, there's this cardinality 8. That is only the case if there are 2 Fridays and they're unrelated. So if you don't share Fridays, so you have to decide whether you intend for Friday to be shared here or not.
I'd say that's the discriminated in it. The definition of the difference between a union and a discriminated union is, do you discriminate between whether it came from class A or class B?
Okay, well, we have to back up because I don't understand. That didn't answer my question. So in the description as written, Friday is declared inside of a scope. Therefore, weekday Friday and weekend Friday are 2 different Fridays. Because they're 2 different Fridays, I can in fact discriminate them in your discriminated union. And in fact, it's cardinality 8, and I agree with that. But the intersection would not give me Friday with cardinality 1 in that case, because those are 2 different Fridays and the intersection's empty. Give me all the things that are the same between the set of planets and the set of weekdays. Well, there's nothing in common between them, so the intersection's empty. So you have to decide whether Friday is in both or Friday is private to each. And make your call. And that changes whether your answers for intersection union and discriminated union, shift plus or minus Friday accordingly.
No, the answer is it's in both, but you have a tag bit that says which one
Okay,
you're
slow down. That's okay, but I said choose. It's in both or it's not. You said it's in both. Okay, great. I would say let's put it up front. Let Friday be some set of things. It's up early, and now it's in both. Great. Which case, in the discriminated union case, you only have 7 entries because it's the same Friday. It's not 2 different Fridays. So the cardinality is 7. Here, where it says 8, I just changed it to a 7. This is the case for Fridays in both.
Right, but the thing that I asked for there, I said weekday plus weekend. I asked for a tagged union in that case. So it should be tagged as to whether it came from a weekday or a weekend.
I didn't hear the ask for a tagged union. I heard, give me all the things that are in both. You have a shared piece. It's in both, but it only counts for one in the end result.
I'm saying the fact that I used plus in my type is my ask for a tagged union.
Okay.
If I want the 2 sets,
Yeah. Then
Without
I claim that
duplicates.
I would have to, under the hood, make a new version of things that's one layer up that has these 2 guys underneath and
Yeah.
splits out Friday twice.
Yeah, but see that this is the difference between what I was talking about earlier with types versus kind of one-off. The type itself is, in this case, a weekday or a weekend. And what you're saying is, I want to create a
Yeah. Friday is both a weekday and a weekend, so that's still the same if there's a single Friday.
yeah, that's not what I was, sorry, I'm having a
So
hard
no-
time putting into words what I'm thinking.
The elements of the discriminated union are not elements of the weekday or the weekend. They're new elements that are very similar.
Okay, that's a new concept I've never heard before. I'm not understanding or reading it in from the syntax you're writing. I'm busily thinking that this is something you just declared a whole new enome that has all the members of both, as opposed to one which took all the members from both and ran them all together in the same set, which got rid of dupes.
right. I would say if you OR 2 enomes together, you should get the set of things that is in one or the other or both. If you
Because the
add
union
2
types is
enums
cardinality
together,
7.
you should get a tagged union that doesn't take anything.
Okay, yeah, I don't know what I would use with that, so I'm not going to implement that directly. I'll let you write that in userland code.
Fair enough.
Yeah, the syntax seems right, at least at the point or the plus or the union on the intersection.
Yeah, I agree with that part. But I just don't. I'm not going to implement plus in whatever I'm doing.
Your implementation of sets don't usually come with a plus.
They're these are sets that share the same value. So in my implementation of sets have the or the plus is the same operation.
So an enum can be thought of as a set of types.
Mm-hmm.
And it can also be thought of as a set of values.
Yeah.
But I think what the challenge here is that Aaron's kind of conflating types and sets as if they were one domain.
Yes.
Which is, and I'm not criticizing, it's perfectly valid. I think various languages do that exact same thing. So I'm just saying it is conflated.
At least it looks right to me what Arvin is trying to say with the and or the or the plus
Honestly,
sign.
I thought it was the exponential types you were going to look at and go like, what?
Oh, I don't terribly care to express those in the raw type system. So as far as I'm concerned, you can have all your exponential types if you're implementing yourself.
Yes, I like your syntax better. You express product types by just showing me the tuple. You express the exponential types by just showing me the map. Like that is a better syntax than like product and caret, which is going to confuse people.
I didn't write any of that syntax. Somebody did something there.
I mean, the other thing is an exponential type is just a function. So like you write the function arrow, and that's your syntax.
Yeah.
Arrow? An arrow?
Yeah, like a dash and then a greater
Oh.
than.
Oh, yes. Okay.
But I'm not, well, okay. I'm not excited about dealing with exponential types. That's weird. Fine.
It
I think
just
it's
falls out
necessary.
of, if you consider tuples to be product types, maps become exponential types.
They are considered, at least to me.
A tuple as a product type, where you just claim I have a pair of anything to anything. Cardinality is, yeah, it's 15.
Right,
That's
the
fine.
cardinality is 1 times the cardinality of the other,
Yeah,
so it's
right.
product.
Yeah, it's fine. But
And if you have a map from A to B, that's cardinality of A to the power
I-
cardinality of B.
I guess I
and-
would stop and say you can make a tuple of weekdays and weekends, and it's exactly a tuple of weekdays and weekends, and I'm not going to answer cardinality questions about it directly in the typing system.
Hmm.
It's just structural recursion. I have a tuple, it has a type on the left and a type on the right. The type on the left is weekday, type on the right is weekend, fine, done. I'm a structural recursive pair of values, pair of types.
So the way we did enums is each enum value is a subclass of its abstract super, which is the enumeration itself.
That's what I was talking
So-
about with my Java case, yeah.
So each day of the week is of type day, but they're singletons, which means that, you know, there is a Monday, a Tuesday, a Wednesday, but there is no a day because it's an abstract.
Yeah,
Can they be represented as integers?
They have a property which is called ordinal, which is their expected implementation unless we have
Okay,
to
but
box them.
at runtime, can the enum collapse to I believe C represent them as in integers?
yeah.
Yeah, I mean, that's our goal is to represent everything as few of bytes as possible of a
Mhm.
fixed size. So
Okay.
we
yeah.
have the same runtime goal as Cliff does. We just have we have a much longer and complicated route to get there.
Okay. Fine. I would try the next time if I get the time to really share my thoughts about dependent types with some examples so we can clear it.
Mostly I'm opposed to dependent types because I don't have a efficient algorithm for typing them, but we can certainly take a look at them.
There is
I
no.
think to some extent you've already implemented them.
No, I don't think so.
But I may, this is one of those terms where my understanding doesn't match Wikipedia.
Yeah, maybe. Yeah,
we
right.
will talk. We will talk about the lambda cubes, terms on terms, terms on types, types on terms,
Right.
and
Yeah. But yes, I mean, I should know it better than I do.
the next time I would try to
All right,
share my
yeah.
thoughts on this.
Oh yeah,
Okay.
Cliff. I figured out what I was confused about, which was that strongly normalizing is not is not implied by recursive types. In particular, there are recursive types that are not terminating. So like in particular, if you just take the omega term and apply it to itself, you'll get a diverging term that never finishes evaluating.
Evaluating or typing? Evaluating.
Yeah.
Yeah.
So,
Yes.
so right. And so the thing is that you can still give it a recursive type.
Yeah.
And so like your
So,
type doesn't.
I have exactly this test case. I've put it in the
Yeah.
Google Docs. It says test 07 somewhere near the earlier part of the Google Docs.
Typing it doesn't mean it would terminate at runtime.
Yes. The type is a function which only takes itself as its first argument and then only calls itself,
Mhm.
which means it will stack overflow and it
Yeah.
never returns. It's a
But the
diversion
Hindley,
term.
but the Hindley milner would come up with a type for
The
it.
classic Hindley milner says, I don't type this. It
Mhm.
blows out.
Okay.
And when you go to a Hindley milner that handles recursive or infinite types, you can type it, which is what I've done, and that's the type I get.
Right. And so, but what you're losing with that is you're losing the property that every program that types terminates.
I never
Oh,
had that
that's-
property in the first place.
That's such a hard property, and if you
what,
have
like,
to,
Coke and Agda and like all these.
yeah, that's
Yeah, I'm
what
not
the
doing
types
that
are-
property.
dependent types can figure out if the function would terminate, or as you say, strongly normalizing that. At least to me means that it will reduce to a value at some point.
Yeah, I'm giving up on that. You can have infinite loops. I can say while true, do a server-like thing, and I have an infinite loop, and I'm okay with that.
So the question is, what properties does your type system ensure? Like it is, I mean,
Well, it gives me the Hindley Milner types.
yeah, but like, I can write a program that spits out random noise, and it says, oh yes, it gives me a type.
Well, you can do that anyhow.
Of
People do
course,
that's what
of course.
fuzzers do. Here's a
Yeah.
random program that's well typed. If you run it, it's kind of dull and boring, but it's well typed. That's fine. I never can guarantee you that your program does something meaningful. I don't understand.
Without the Alan, without the dependent types, you can write a program that the type system cannot prove it will terminate, but you can write a unit test that says the number from 1 to the maximum integer allowed that would test does it terminate at runtime. If you have a dependent type system, that can happen at the type level, but you cannot guarantee it will terminate.
You can't
without
tell it
running
terminates.
without running it.
No, even with running it, you can't tell it terminates. All you can tell is it hasn't terminated yet.
Oh, yep. That's another way. Okay.
Well, no, so like the question is, I have an AA program. I run through the type checker. It gives me a type. Like, what do I know about the program? What
Will not throw a type error at runtime.
Yeah, that's
Okay, wait. I didn't hear Alan because you and I talked and it cut out Alan's sound. So Alan, say again.
So the question is, what sort of bad behavior is ruled out by the type system? Like if I know a program has a type, what does that type, the existence of that type, tell me about the program?
Okay, it will tell you that you didn't try to do an application on a non-function. You didn't try to call a non-function, for instance.
Okay.
It tells you that the primitives have operands of the type that they're allowed to have. So increment and decrement, add, subtract, multiply, divide, take an int for their arguments and return an int result. They'll tell you that you have those correct.
Yeah, I mean, types simply provide variable levels of constraints depending on the language. I mean, in Python, for example, there's very little constraint, and if you don't like those constraints, you can add or remove them on the fly, right? And in Java, there's a different type of set of constraints, which is be careful with null. And so it's like different languages have different.
You have to be careful with null in Python too.
Sorry, I'm trying to be humorous as I explain this, but I mean type system. So I've got this object-oriented whatever book by Bertrand Meyer, right? Who's like, if it compiles, it will work correctly always, right? That's his theory on programming languages, right? And I hate the result. It looks like someone shat all over the book. But it's not that it's a bad goal. It's that to put these concepts into a language that you can compose out of terminal pieces, the complexity of composition, just to reach each additional goal, the complexity of composition grows inordinately, right? So you can have a strongly typed system with a strongly statically typed system, but you still have all sorts of runtime type errors, errors. You could. What I'm saying is the language can choose which errors it's going to check at compile time, and even though it would like to find more errors at compile time, it chooses not to because the cost of doing so. I'm not talking computational cost, which is nothing. I'm talking about the cost to the writer and the reader just gets ridiculous.
So I did a startup called Norensic looking for fraud in the stock market. The Java program was well typed and compiled and ran, did something useful, but did it detect fraud in the stock market or not? Can I prove it at typing time? No, of course not. So did it do something useful? I don't know. I tried to. The typing system could not tell me it was doing something useful.
I'm trying to remember some quote that summarized the Alan question pretty much entirely. The typing correct programs doesn't check, but all the typed programs is not guaranteed to be correct. So something like that. I will look it up.
Yeah, go look at it. There's a quote there somewhere, right?
Yeah.
The typing is necessary but not sufficient to get a program that does what I want it to do because the computer is not yet reading my mind.
Yeah, the program that the types checks or a line up doesn't mean the program is correct.
Yeah.
but the type incorrect program, they are not correct or something like that.
Right. If the program's not type correct, it will fail sooner rather than later, kind of thing. So it helps me get further along. That's all the typings are doing.
Yeah.
But
There's some, okay.
did that actually answer your underlying question?
Yeah, I mean, I don't know. I mean, you gave a short answer, which I'm going to look back at the video and pull out as a quote in my. So, but it's like, because like that was the useful answer in my view, was that like what was it? It was like not applying functions as values and using and then making sure that primitives are applied to the right types. But
same thing you get out of anyone else doing, ML and Haskell doing types. I happen to get more precision in some places. So either I can type more programs or I can tell you more about the typed program than the classic, but it's not, the end goal is simply to get rid of a large class of errors where I did a stupid and, classic JavaScript fail, none is not a function. And oh God, now go debug, none is not a function. Jesus Christ, what a mess.
Yeah, because I mean, you look at these academic type system papers and they're all like sound, they're decidable, they have all these nice properties, and then you try to use them and they're like, they don't work. They're completely
Right.
No.
Right, because their goal is different.
Yeah.
Some of those warnings are really convenient. Like when I told you this thing was const and then I mutated it, it's nice to have something that's like, did you want this to be const or not? Because you give me contradictory information here. So you need to work that out with yourself before you ask the compiler to do something.
Yeah.
But let me quickly go through the list of products built in Idris. I'm done.
That was very quick.
Yeah. So
All good.
It's not that it's a waste of time. It's an amazing set of things that they've accomplished. It's just that they were never trying to build things other than Idris.
Yeah. You're trying to learn something about how the mathematics of the universe work as opposed
Right.
to.
Right, which is really cool. I think it's really cool. I'm glad I'm not working
I
on
love
it.
Space Shuttle and Hubble and cosmology, but it doesn't have a whole lot to say about my day-to-day life. It doesn't put groceries in the grocery store on my table, but it's really fun to know about this shit.
Yeah. The practicality of the things.
Maybe it becomes practical at some future date. That's the hope.
Well, I think what they do is they solve certain problems that are way out there. Someone sees the way they solve it and say, I could use something similar in Go or in Scala or So there's a community of people getting ideas from the long hard work in these theoretical systems.
Yeah.
All right, I think we're running down the point where we all say yes at each other very rapidly. It's all good and it's fun. We're on the same page, but I'm going to go eat lunch.
I guess my last question was just, how do you plan to print out this information?
You just saw it.
Like if I violate a type, is it going to be like, hey, you said it was this type, but it's actually this type. Please compare them. Like, I worry these are going to get nastily nested in ways that make it hard to compare.
No. We just feed it back into the C++ template engine from 1990, and it comes out beautiful.
I have to know, I used that sucker when I was both grad school and early days at Hotspot. Seafront. Holy crap, your error messages were.
I didn't have a monitor big enough.
Yes, they would scroll for, never mind.
Yeah.
So I'm spending some effort to get better type errors. The first thing that comes out of the typing theory side is that I had a canonical error for every program. You get a strong type, always. Now that type may say shit like cannot unify one in string, but that's the strong answer for the type. So because of that, I can now turn that back into however I want for what the error message should be. Like, what is the right error message here? And it varies by person and their education level and their programming junior versus senior engineering and shit like that. But at least had the opportunity to give you a reliable, dependable error message now. So I've spent a fair amount of time in AA getting better error messages out. Sometimes I thread through more bits than you would otherwise need just so I can get an error message. in particular, I pass along, and a lot of folks pass along the parsing point where of excitement. Sometimes it's two of them. And if an error appears, the parse point, which just is an offset into a file, is a line marker that I can pull it out for the error message. Here's a line, and here, from here to here, I detected blah, 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 and those show up in my AA types, not the theoretical type guy. He just blows out in a type. He gives me a type. You only get syntax errors if you fail to write a valid syntactical lambda calculus. But if you get a type error, that is the error. It's not very pretty though. So AA takes those and makes them pretty by knowing where they came from. So I do track the backtrack.
The where they came from gets you something that smells like a stack trace.
No,
Here
it's a
is a
typing.
definition point. Here is a use point. Here's
I see.
everywhere it went in between.
I'm not there right now. What I'm doing right now is detecting some program point where you added a constraint, some program point where you added another constraint, and then I can go to those 2 points, but not necessarily the path in between, and say these two things are in conflict.
Yeah. And we do bidirectional typing, so we have this other issue where we'll go back and forth in this bidirectional, trying to narrow and narrow until we can find the optimal solution for something. But each time you hit one of the edges, there's an error. That's why you have to turn around and go the other way. So now you get done with, let's say you have a lambda inside a lambda inside a lambda inside a lambda with an error somewhere in there. You could end up with 2 to the 4th, I don't know, whatever, 16. You could end up with 16 or 64, I don't know what the number is, but a bunch of errors. But you only want to report one. And the question is, which one do you report? How do you tell the developer, if you fix this thing, this is probably what you meant to, and that's a tough one.
I have because I have a strong answer for errors. Errors are a type, and they give me an exact answer. And every program that passes syntax is typable, but the type might include an error type. I can say something stronger about what the error needs to look like. For the case of the flow answers, it's easy. Once you hit an error point, the lattice value drops to all, and the all propagates forward, and everyone who eats an all passes on an all, and that's your error type. So I look at the perimeter where you went from not the all to an all on the flow types and say, this is where I picked up the error. In the Hindley Milner types, I get it when I do a unification between things that I hate. And there I have to just pick up the tracking point from each of them and said, you two guys unified, and at this point I declared an error. Next time I unify with that error, I'll pick up more tracking points, and I haven't yet sorted out how I'm going to filter them all out.
Yeah, so the scenario I picture is I have some kind of web stack. Yeah. It hands me a request object. It expects me to hand it back a response object. My whole web server is over here.
Yeah.
I'm going to get something that says, hey, you took a thing out of the request object. You put a thing into the response object. Web framework has a hard disagreement with other side of web framework.
Well, and
it's like, right, but I got a type because you gave it to me, and it's conflicting with an outgoing constraint because I gave it to you, but I may actually be in the middle of this call chain. And it's the thing that I just changed that is probably broken, not something in the web framework, even if the constraints on both sides that are disagreeing with each other come from the framework and just met in my code.
So you remove the word web and you say, I have a compilation unit, a module, a typing set. It has a peripheral type that wants to be, it has a return type it wants to be. Those are constraints I'm handling from outside this area. I pass this thing in, it comes in the middle somewhere, and it does something. I pass in the reverse constraint from the result because it's bidirectional. Hindley Milner is bidirectional typing. You pass it backwards, somewhere in the middle I get a conflict. Okay, and now how do I report where the conflict came from? And that's exactly the same problem we've been talking all along. There's no difference. It's in my flow thing going forward, I have an easier answer. In the Hindley Milner type, I have here are all the things that summed up to a fail. I don't know if I have a pick one and fix it and all the fails go away. It could be that you have to fix several things. So right now, my theory is I'm going to accumulate all the fail points and say each of these is uniquely a fail, and there may be several. And it's going to be the sum of at this point, and at this point, and at this point, we've all agreed, blah, 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 blah. And at this point, we're agreeing yada, 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 and blah, 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 and yada, yada, disallow. And I don't know necessarily how to, I'll have them all. I don't know necessarily how to pick, or if it makes sense to pick, or just report them.
So
Right
if I
here
have a
you-
bunch of stuff that asserts A on one side and asserts B on another,
Yeah.
and it propagates for a while
Yeah.
until I get to some middle section that's like all the way from here to there. I don't
Yeah.
actually care if it's A or B.
Yeah.
It could go either way.
Right. So much of Hindley Milner passes along without adding constraints. And that, for me, also passes along the point where the constraint got picked up.
Okay. That makes sense.
And it does it with this union find. Actually, you pick up the constraint at the, however you pick up the constraint, and you put it on a type variable with the constraint, with the point where you picked it up goes into the type variable. The type variable then unifies a bunch of other type variables, typically having nothing to do except unifying. And then eventually you unify two guys who hate each other. But the unification made 2 to 1. At the time they made 2 to 1, you need to bring in the program points from them both, but they're typically, it's like all the same, or I didn't actually have a constraint in itself, except where I started from, like whatever. I can step you through. This gets, everybody starts out with a type variable and everyone starts out with a program point. And then I unify two guys together, and typically they're just copying A to B to C to D to E. And then I don't care for your program point because you were just a copy from A to B. And I'll at that point I can tell, I can just throw away whatever your program point was. But as soon as I get, here I have a string and here I have a function, and I picked up a constraint that took you from a leaf to a string, I now need to declare this is the interesting program point that did it. And if I say I'm a leaf and I merge with you, I don't care where you came from. I'm a leaf and I merged, leaf, and you're a function pointer and you merge, then I still have just one function pointer where you came from, one leaf. And when you bonk heads together at that point, I'm going to carry. I picked up leaf stringiness from here. I picked up functioniness from there. Now I have them both. So
The error is hard because you generally then doesn't have a static annotations. And
yes, yeah. If you add user written annotations as a constraint, I will take them over
As
other
a-
things directly.
Yeah, you can say this confronted what I was expecting directly, or you told me that type should be, and I will go with it, and I can report it back. That's
Yeah.
Mm.
But yeah, as soon as you said, I think this is supposed to be an int, I'm
Mm.
going to believe you.
Yeah.
And that gives the developer a path toward cleaner errors. I could get something that blows up at me and is like, this thing needs an address and a name and a blah, 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 blah. And I was like, so much text. Okay, this is a person class.
Yeah.
Boom.
Okay.
Now
Right.
this wasn't a person class at this point. Great. Now I can clean up, make
I've
my
seen
errors
this
much
as
simpler.
a way to
Yeah.
start to diagnose errors in complicated typing systems like you get out of Scala or Haskell. You got an error, you just didn't have enough. You didn't have the type annotations.
Right.
You throw in type annotations. I know this is supposed to be a blah, and suddenly your error shrinks and narrows. Yeah.
Yeah, I really like that as a way to help the developer put in the types at the time that they're debugging for the things they think
Yeah.
they know.
All right, I have company
Okay,
here
guys.
now, and it's lunch, so I'm going to break it.
okay.
It's good.
Thank you.
This is a fun conversation
Okay.
until we meet again.
Yep. Bye, guys.